Okay, sorry, just setting up things around me. If you guys forgive me, I was just setting up some stuff. Okay, so this is where we are at. Okay, yeah, no, just let's start now. Okay, so if you remember last time we did reaction of metals, right? So reactivity of metals, what we were doing, we had a list of reactivity of metals, and it would come in handy to think about them right now. I gave you a way of remembering, okay, you had in the reactivity of metals, you know, of metals. Walaikum salam, Umama. Okay, so we are doing this. Yeah, okay. So the reactivity of metals, we start with group 1. So we had sodium, potassium, right? Then we had group 2. What was group 2? So we had sodium, potassium. Yeah. And then we had group 2, which was calcium, the guy at the bottom below, and then magnesium. Then we had group 3. Kaun sa tha? Aluminum. Then after aluminum we had group 4. That was which one? Carbon. And carbon ke form baad we had the same element that was also amphoteric like aluminum. That's how I remember. Zinc. Zinc ke baad you have the other guy that you need to learn, iron. Yep, exactly. And then you have lead, then hydrogen, then what was it? Copper and silver. Lead, hydrogen, copper and silver. I have less space, so yeah, this is carbon. And the thing with that is, okay, today's class mein, this guy will be very important and hydrogen will be very important. And the reason for that is because we said we are going to extract metals using reduction. So the goal of today is that. And the basic premise of this idea, reduction kya hota hai? What is reduction? Reduction is basically the process by something gains electrons. So, and if there is reduction, there's also going to be oxidation. So for example, here is an example of an oxidation of a reaction. While copper 2 plus gaining 2 electrons is an example of reduction of copper. Yeah. Reduction of copper. Okay. Yeah. So far that's what we are seeing. Yeah. And okay. That's what we have. Yep. Yeah. So that's what we're going to work on. Now, if you, yeah. So extraction of metals through the reaction of reduction. Now, what is the basic principle for this? The basic principle this works on is, if I take a more reactive metal reacts with a compound of a less reactive metal, and what does it produce? It produces the more reactive metal becomes the compound, and the less reactive metal is deposited as pure metal. All right. Yeah. Okay. Now that's the basic idea. Now that's what we're going to present. Now, for those of you who've done extraction of iron, that's exactly what happens there. Extraction of copper, that's exactly what happens there. So those are the things that we want to think about and work on, because uska kaam na real life mein bahut zyada hai. Okay. Now, one of the compounds we use, because you see, we're going to talk about industrial process. Industrial process ke liye, we need something that is, this is 01, 02, 03, Rahimam. This is 1 year mein pura O levels ho raha hai yaar. Alright? This is chemistry. You can call it O2, you can call it O3. This chapter in some schools is done in O2, in some schools is done in O3. Alright? Extraction of aluminum and iron, and in some cases understanding also copper. Alright? Copper also. Okay? I see a lot of new faces in this class, and that's alright, that's great, but let's focus on, let me just get this sorted, and let me just, yeah. Now, where are we right now? What we were talking about, thank you, Rahim, I guess. So, so the first thing, remember we said copper, right? And so carbon, sorry. So I'm going to first talk about using carbon. Sahi hai? Now the thing with that is carbon ka khususiyat kya hai? If carbon can be easily oxidized to carbon dioxide. In fact, even carbon monoxide can be oxidized to carbon dioxide. And this change is oxidation because both of them are gaining oxygen. But instead of just looking in terms of oxygen, let me write this again. My writing became bad. I'm still getting used to this platform. All right. Is that this? Let me just, okay, write this again. So मैं क्या कह रहा था आप लोगों को? Carbon. Oh, screw it. All right. Now, one good thing about carbon is it's cheap. Carbon in the form of graphite is cheap. You can get it in coal and other forms. Coal, I meant. You know, coal and the forms. It is low cost. And what property I want to use of carbon is that I can take carbon and burn it with excess oxygen to make it carbon dioxide. I can also have used carbon monoxide to make it carbon dioxide. ये खुसूसियत है carbon की. It gets easily oxidized. Why? It goes from oxidation 0 to oxidation plus 4. Here it goes from oxidation plus 2 to plus 4. Remember we just did redox earlier? So here it goes from plus 2 to plus 4. So we just did redox earlier, and that comes in handy understanding that here oxidation ho rahi hai. So we are going to use the oxidation of carbon. Because when we use the oxidation of carbon, we are using it as a reducing agent. So what we're going to do is we're going to use it as a reducing agent. Because what's a reducing agent? That it reduces some other substance, but itself gets oxidized. Yeah? That's what a reducing agent is. So far following? Yeah? Huh, guys? Yep. Okay. So moving on. That's the idea. Now, क्यों हम बात कर रहे हैं carbon से? Because the idea is that where am I going to use this information? Acha, so carbon can get easily oxidized. Do you follow this? Can I get a thumbs up for this? It's cheap and it gets readily oxidized. Yeah? Yes. All fine. अच्छा इसका काम क्या है? Where am I going to use this? इसका काम ये है boys and girls कि इसको हम इस तरह इस्तेमाल करेंगे. What we're going to do is we're going to take a metal, because okay, this is what I'm going to write. So we can use carbon to extract a metal that is less reactive than carbon. Now somebody asked me, okay, we're only going to study aluminum and carbon iron's extraction, because those are the examples of the extraction. You're supposed to know that carbon can be used to extract any element less reactive than carbon, any metal. And the syllabus says use iron as example. Okay, so that's an example, for example. All right. My voice is lagging. Yeah. Oh, by the way, what do you mean it's lagging? Is it after I've spoken or written, or what? How do you know it's lagging? You know what lag means? That means it's behind. Like my mouth is moving, but my voice is behind. But you guys can't even see my mouth, can you? If you are listening to me on, I know, some people finding it. All right. A good example, okay, the crude example is this. You take iron oxide. Okay? What does extraction mean? Understand extraction ka matlab ye hota hai. What it means is, take the element out of a compound and make it its metal. And way we use that is we use this with carbon. And what does is carbon takes away the oxygen from iron. It is redox, because what's happening to iron is losing a hydrogen. Iron is going from an oxidation state of +3 to an oxidation state of 0, while carbon is going from an oxidation state of 0 to an oxidation state of +3. So it is Fe2O3, Saad. I mean, I'm not balanced it. Again, I'm not balanced the equation yet. I will balance the equation, but it is Fe2O3. Did I write Fe2O3? Thank you, Arisha, for your lovely, kind words. Yeah. Thank you. All right. Saad, do you understand what I'm saying? I'm just writing the full equation. I'm not balancing the equation, but you're saying it's Fe2O3. Where is it Fe2O? I did not write Fe2O3. I did. So my point to show you was this. Let me write the full balanced equation. कि हमने शुरू किया, हमारा मकसद था कि to take Fe2O3 and convert it to iron. And in this process, carbon gets converted to carbon dioxide. Balance हम बाद में करेंगे. We balance in a minute. Iron goes from +3 state to 0. That is a reduction reaction. Hence the extraction of iron through reduction. While carbon is getting oxidized from 0 to +4. So you cannot have reduction without oxidation. So we have oxidation and reduction. And overall it is redox, this reaction. Okay, it is redox. But carbon got oxidized, iron got reduced. This is the general cases of the extraction of and so, by the way, you don't have to limit this to iron. If you remember, why did I mention this with the reactivity series? Because अगर याद होगा, carbon से ऊपर क्या है? Let me write them down. So remember, carbon से ऊपर potassium था, sodium, calcium, magnesium, aluminum. We cannot use this for that. Okay, if I can probably make a nice little line, I can only use this for anything below carbon. So what's below carbon? If you remember, right below carbon was zinc. I can use this method for zinc. I can use this metal for iron. I can also use this metal for lead. I can also use this method for hydrogen. And I can also use this method for anything below that. So these guys can be extracted by using carbon. Now extraction का मतलब ये होता है कि ore को metal बनाना. What's an ore? Ore is most likely an oxide. Okay, so basically metal oxide to metal, we can use carbon, but only for these guys, not for guys that are more reactive than carbon. All right, does that make sense? All right, then what's up after that? So that's what we have so far, right? Then, so now obviously we'll have to do the industrial process, but first let's write the full reaction. Ore can be a metal oxide. Ore का मतलब होता है how we find them in the everyday life, and like as like you could say in the impure form there generally are carbonates or वो क्या कहते हैं उसको, carbonates or oxides generally. All right, now so far okay. Then what am I looking at? So I'm going to ask you guys to do this. Take a minute, and so now let's write the balanced equation for the basic extraction of iron from carbon. I want you guys to try balancing this right now. All right, please, for me. Yeah, I know it's a problem, Arisha. I'm doing it better next time. All right, if you can wait for a bit. Wait for a few days. Just give me 1 second. All right. Okay, so thank you. A lot of you have done this. Awesome. Yup, thank you for sharing. So it is exactly that. All of you, awesome. So when you balance this, you got to balance, see the 2 and the 3. The 3 bothers everybody. The trick is always, if you get an odd number and an even number, you first make the odd number into an even number by multiplying by 2. That'll be the fastest way of balancing it. So if you see an odd number here, multiplied by 2 becomes an even. So that means 6 oxygens. That means 6 oxygens. And you get that, that makes it 3 carbons, and that makes it 4 irons. That's how I always think about this. All right. Now this is that. On the other hand, this is that happening. Now, so this is the overall reaction. But understand, okay, so this is the chemical change happening. But now if we do the industrial process, because when we do industrial process, remember जो industry होती है, the industrial process needs to make it fast and cheap. So the industrial process is a little different than this. What is the industrial process? Now the industrial process is a little different. How is it a little different? Well, firstly, this is a solid and this is a solid, and two solids react very slowly, like me talking right now. They react extremely slowly. ठीक है, ये सीन होता है. Now okay, now how do I fix this? You see, the problem is, how do I fix this? So remember हम यहाँ क्या कर रहे थे? We were getting carbon की oxidized and getting iron reduced. So, but now the reaction is very slow with solid. So if I can convert them into a gas, meaning that a solid reacting with a gas is very fast. Now, you might wonder, why is that very fast? Okay. No, even powder form maybe will be very slow, Abdul. Because the particles have to move and come into collision for them to react pretty fast. And that becomes the challenge. Okay, how do I get these guys to react faster? How do I let them react faster? Powder form is one. The other form is one of them make them into a gas. So what, through trial and error, what we have figured out is that, you know what? Instead of reducing iron oxide using carbon, what if I could reduce it using carbon monoxide? चीज़ तो वो भी होगा, मुझे फिर भी आयरन चाहिए और कार्बन डाइऑक्साइड चाहिए. But if I start with carbon monoxide instead of carbon, it's still a reaction. क्यों? Because you can balance it and you can see, well, 2 वहाँ चाहिए, 3 4, I need 2, तो 3 times 2 मैं ये करूँगा. So that's 4 iron, 6. So 3, and if I put 3 there, then it starts becoming tricky, because now I've got 9. So I've got to find a different way of balancing this. First of all, balancing becomes difficult. Sorry, somebody's saying something. Yes, by using carbon monoxide. So what I realize is that I don't need this to be 2. I actually don't need this to be 2. But when I do that 3, that's I just put 2 here and this is balanced, because I've got 6 oxygens here. So I can do this also. And why? Because इसमें carbon तो oxidize हो रहा है, +2 से +4 हो रहा है, and iron is becoming +3 to 0. This reaction is absolutely possible. और इसका added फायदा क्या है? This will be faster industrially because you have a solid and you have a gas. You see that? So solid and gas make the reaction go faster. That's the game. All right. Now, so that's what happens. So industrially, idea ये था कि reduction with carbon था. Now, carbon का impure form, by the way, is also called coke. So we do say iron oxide. हम चाह ये रहे थे कि iron oxide plus coke becomes iron and carbon dioxide. We say na extraction of iron from coke, that coke. But what we end up doing is we take the iron oxide, the iron 3 oxide, and react that with carbon monoxide, and we get iron and we get carbon dioxide. And so that's the industrial process of the blast furnace. All right. Okay. Yeah. Anyway, so coke, not the coke that you drink, for the coke for chemists is different. That is carbon. No, not the drink. Come on, what's wrong with you? What's wrong with you? What's wrong with you? Laiba, you were right earlier. Yeah, you saw that, right? Awesome. Anyways, so basically that's what I want. So what I want to achieve is this. Okay, I know repetition or but this is how you'll remember it. That I am ending up removing iron from iron oxide using coke. Fayda kya hai? Gas and solid can react to produce a pure solid and even gas here. So that's how I end up doing this. Yeah, it's faster. Okay. Now, on the other hand, हम करते किस तरह हैं? We don't start off with carbon monoxide. Coke is carbon. Acha, now the problem with this is that ये gas ना poisonous है. We don't store it. We don't have stores of carbon monoxide. We have coke, which is carbon. Arisha, we had done oxidation states. And the oxidation state का हमने किया था कि oxygen is always -2. So this must be +2 to make it 0. And if oxygen is -2 here and there are 2 of them, then carbon is X, and then that works out to be +4 using oxidation states. All right. Then the second thing was, so मैं कहता this is poisonous. This fellow is poisonous. So we don't start off with carbon monoxide. So देखो I am layering it up. We wanted to reduce carbon from coke, but we ended up using carbon monoxide. But what I want to tell you is that initially we still use coke. हम start off coke से ही करते हैं. And what is coke? Carbon. Now how do I start off with coke? Acha, what we do is it's hard to also control the combustion of carbon. So पहले हम carbon को fully देते हैं oxygen, and all of the carbon that I have becomes carbon dioxide. And then I'm glad, Saad. I'm glad. Yeah. You're welcome. Then, so what we do is, listen, we want carbon monoxide, but carbon monoxide is hard to make, hard to store beforehand. तो हम उसको reaction में बनाते हैं. We make it in the reaction. How do you make it in the reaction? We first take carbon and we make it into carbon dioxide. And then we take this carbon dioxide and we add it to more carbon from before. And when you do that, it becomes carbon monoxide. Because what happens is the carbon dioxide that came from, the previous step that I finally get to draw a circle around loses one carbon to become carbon monoxide. Now remember, the carbon dioxide came from the previous step. The same carbon dioxide loses one oxygen to you can call it more carbon. Oh, come on. Let's see. Hey, it can write text. Let's see if this works. Yeah. So this is what we have. So carbon monoxide with more carbon or coke will become carbon monoxide. Now this carbon monoxide is then used by what? Fe2O3. So then Fe2O3 uses the carbon monoxide to become carbon dioxide. Come on. Yeah. And obviously not the same ratio of equation. That's 3 and 3. But moles फर्क हो जाते हैं, but चीज़ वही रहती है. Okay. Are you following this? Huh, guys? So yes, so the carbon actually is the reducing agent in both cases, you see, because पहले वाले में it's going from 0 to +4. So यहाँ भी reducing agent है. हाँ, और here you can call it a reducing agent. Yes, I know why you asked that, Laiba. Beautiful question. Love it absolutely. Because this carbon, then I'm going to make a triangle around, which is so weird. The carbon that I have made a triangle around is acting as a reducing agent, and the carbon dioxide is acting as the oxidizing agent in, let's call it reaction number 1, reaction number 2, reaction number 3. So in reaction number 2, carbon dioxide is becoming carbon monoxide through reduction, and who's reducing it? Carbon. No, Saad, trust me, the number of reactions is not like कि आपने वो बंदा एक ही बंदा काम कर रहा है. That's the thing. You see, sometimes if I ask you, eating, drinking water with the food and breathing will take less time than building a 5-story building. Just because something has multiple tasks doesn't make it slower. You can finish your food, dinner, have water and breathe, and some of you might even fart in the same half an hour. But if I ask you to build a house by brick, that's not going to take half an hour. So my point being, Saad, with that beautiful example, is that just because there are 3 reactions doesn't make it slower than a 1 reaction. Do you get that? And the reason why all of these 3 are going to happen faster is because all of them have at least 1 gas. You see, all of them have at least 1 gas. If you have to have 1 gas, yes, Arisha, if you have to have 1 gas, the reaction will be faster. Aqueous, liquid or gas react very fast. Solids react slower. So you have to have one of them as gas. You have to. Else it ain't gonna work out, son. Alright? It ain't gonna work out. So I hope I make sense to you guys so far. Now this is the extraction of iron using a blast furnace. Alright? Literally this is exactly what happens when you extract iron from the blast furnace. Okay? And yeah. Okay? Okay, so that's the reaction. Okay? So you can remember this. There is a little part missing, but I'll tell that later. So far, what's happening is, okay, and you can use this to basically extract iron. Now, the beauty is, one other beauty is, do you want to know what's more beautiful than this, in addition to this, is that ये जो आपकी reaction है ना, this produce lots of heat, which then melts this guy. And then through this process we get molten iron. जब iron molten होता है तो it is easily removed from the system. वो गीला गीला पानी की तरह घूमता रहता है and it's removed from the system. Saad, in fact, this is it except for a thing or two. But this is the crux of it. So, what am I saying again? So, what do? We take carbon, we burn it in oxygen. We heat it with oxygen, it produces carbon dioxide, gives lots of energy. And then we pass that through more carbon and it becomes carbon monoxide. Now we got that hot gas and lots of heat, and that carbon monoxide then is passed over the ore of oxygen, iron 3 oxide, and it ends up making iron and 3 moles of CO2. And this is in the molten form. Okay, that's the procedure. Literally, this is what's happening in the real life. There's one other thing that happens, which is to do with impurities. Because in the real world, this guy is impure. And to prevent carbon reacting with, and to prevent our compound having impurities, we need to remove them. Yes, Fariha. Wow, wow is what? Wow is the fact that this is easy? Yes. That's my job, man. That's my job, to make things look easy. Yes, yes, yes. You know, I think I have, I wish, not as many people come for my classes, because I like teaching English maybe. And they're like, sir, please, I hope you guys are okay with me doing it in English. You spend a whole month doing this in English? Chalo. Okay. Thank you, Fariha. I try. I'm not amazing. I just want to help you guys do this as fast as possible and in examples that are as memorable as possible. So we had this. To make kya raha tha? Basically, what we do is we have some impurities. Now, in the real world, we can have acidic impurities. ठीक है? काफी दफा. And acidic impurities are bad. And you know why they're bad for metals? Because metals do react with acids. So extraction के बाद मैं कुछ और reactions कराऊंगा आपको. Okay? And then one of them is reaction with acids. So the chapter after this is acid bases. So I'm waiting to do that together with this. All right? And electrolysis. All three are together. Metals, acid bases, electrolysis, all tied. So I'm going to do this, and acid bases, and then electrolysis. So metals will corrode with acid, yes. So we want to remove acidic impurities. So how do you remove? So now let's talk about this. Okay? So if I have acidic impurity, what can I remove it with? I need to react with. So now this is something that people will have to learn right now, because we have to do acid bases after this, is that calcium oxide is a good guy that removes acidic impurities. Okay? Well, if it is to do with what you might call it, if we remove the impurities, then he's saying. So we want calcium oxide. Now the problem is calcium oxide भी दुनिया में महंगा है. तो now हम use कर सकते हैं calcium oxide, but man is smart. Man says, why bother with getting calcium oxide? Well, I have a cheaper version of this. I get it from limestone. Now limestone is by far one of the cheapest things we use for everything. It is what we use for cement also, and it's also what we use to make houses. Our blocks, everything, bricks are made from limestone. It is, and what is limestone? Limestone is an impure version of calcium carbonate. Calcium carbonate, absolutely beautiful, which is why we studied calcium is such an important thing for us. Hallelujah, you guys know this. So what we say is, you know what? I don't need to give calcium oxide. What if I can make calcium oxide? We are definitely getting a lot of heat. Remember, where is the heat in the reaction coming from? It's coming from oxygen to make carbon dioxide. Remember, this produces lots of heat, and heat production is part of chemical reactions, and we'll do in energetics. All right? Now, so what we do is this heat we take and we introduce calcium carbonate to the mixture. Now, when we introduce calcium carbonate to the mixture, the heat for calcium carbonate converts calcium carbonate to carbon dioxide. Now, I believe that you have done types of chemical reactions with Sir Abul. This reaction is called decomposition. So the heat from the burning of carbon that we did decomposes calcium carbonate to calcium oxide. Yep. And that calcium oxide we use here to remove the impurity to make it a compound. Do you see the cycle? Now, I'll specify the impurity reaction again. Let me say this to you. So how do we remove impurity? Well, we start off with calcium carbonate. And what we do is we use the heat that we're already making. So instead of using calcium oxide, we make it. And we also make carbon dioxide. Remember, what is carbon dioxide used for? Carbon dioxide was the guy we were already using with carbon to make carbon monoxide. So, no. We don't have to do it that way, Saad. We separate them out. Calcium and iron have nothing to do with each other. So we separate it out. So we have calcium oxide and this. So what we do is, we do this. We have this. So, so remember, this carbon dioxide was already coming from carbon becoming carbon dioxide. Now we get it from here and we get it from here. So we don't waste anything. And this calcium oxide is then used with what fellow? Then it reacts with an impurity. Now this is a very common impurity, silica. This is found in sand. And what it does is, it converts it into a compound called silicate. Yeah? Some of you have done this already, so you already are ahead of me. Slag. Yes. So this is what you call slag. Now silicate is SiO3 2-. It's very much like carbonate, so don't get confused too much. They are those, complex ion scalo or polyatomic ion scalo or compound ion scalo, whatever you call them. So, yes, Izan, absolutely. So think about this. So let me give you an idea. So basically your iron ore is what? Is a mixture of Fe2O3 and SiO2. Okay? Now Fe2O3 we want, and we do not want this. We want to remove this, and we want to make it into something that won't react with something. Like we want to convert this into slag. We want to react it away because it falls down. Otherwise it gets mixed up in the mixture. Now the problem with silica is it has very, very high melting point, so we can't melt it. So वो मसला हो जाता है हमारे पास उससे. So let me explain this again. So Arisha, in the real, I'm trying to again give you as little as a complexity as possible, and obviously some things end up being, oh, you just have to learn this, but I'm trying not to. I'm trying to give you explanations for it. So होता क्या है? We start off with carbon. So what we start off with, I am going to write them. There's no highlighter in this. It's so sucky, by the way. There's not even a black background. It's so sucky. But after the last Zoom incident, I'm also very agitated by people, because Zoom pe free classes karna is so difficult. You can't keep a counter on people. You have to organize groups and everything. So not silica. No, silica doesn't have a higher density than iron. Ali Abbas, no, it doesn't. So you start off with this. Now this heat, and I'm going to do the impurities in red. So this heat from this reaction that is produced, then I take my calcium carbonate, and that heat makes me more carbon dioxide but calcium oxide also. And why do I need calcium oxide? Because calcium oxide can react with SiO2 to convert it into something that I can melt. It converts to slag and it is removed from my system. If I don't convert it, it can't be removed. So by removing it can only happen if I make it slag. And this carbon dioxide and this carbon dioxide are then used to react with more carbon to become carbon monoxide. And that carbon monoxide reacts with, so Fe2O3 to make Fe and CO2. So in the end, you get what? You get lots of carbon dioxide. We don't care about that. You get iron and you get slag. So iron has been reduced. Yeah. So carbon, in the end, the story is that carbon became carbon, what do you call it? Carbon became carbon monoxide, which then was converted to carbon dioxide, carbon monoxide, and the carbon monoxide came back to carbon dioxide. That's the journey of carbon. The silica, the calcium carbonate was only there to remove impurities. All right. In this case, ये दोनों ना liquid होंगे. In the real world, these guys are liquid now. Which one? Sorry, the two things I need. Let me put them in circle now. So I'm going to put them in a blue circle. Okay. So those are the final things made in the solid form. You see, carbon dioxide is given off as gas, so we don't care about that. But okay, one second. Come on. So these guys, yeah. Now both of these that I've circled in blue are now liquefied. So we extract them as tapped liquid and then we solidify them later. Okay. All right. And we don't, so yeah. So pig iron is another impure form. Yes, in this case, a slag will be molten. Yes. Remember, ionic compounds, even though they have a high melting point, is still lower than silicon dioxide many times. तो बेसिकली हो ये रहा था कि इतनी गर्मी थी, इतनी हीट थी कि ये जो आपका सॉलिड था और ये आपका सॉलिड था, ये आपका लिक्विड बना रहा है. एंड येस दैट रिएक्शन माइट बी स्लो, बट वो इतनी कम होती है कि आई डोंट केयर इफ दिस इज स्लो और नॉट. वाइल यहाँ गैस और सॉलिड लिक्विड बनाता है आयरन, और कार्बन डाइऑक्साइड गैस बन जाता है. So the states also matter. You see, in that temperature, not in that temperature, iron is a liquid and slag is a liquid. And it's easier to extract liquids out in that system. While solid, gas. But you see, you need to remember that the first parts of the class were the more important parts. Which parts? The following, what was happening to iron and what was happening to carbon. Remember, we started off with the overall reaction, then we used coke because we said कि यार कार्बन से कार्बन डाइऑक्साइड बनाएंगे, जिससे हम कार्बन मोनोऑक्साइड बनाएंगे, जिससे हम फिर आयरन निकालेंगे. That's the important bit. The impurities are just additional thing to remember at the end. Most of what is happening is the main stuff. Do you follow this? And the temperatures get really high. This is around 1000 degrees. 700 to 1000 degrees. Okay, start off with 7,000 and then slowly. And by the way, then when they're both liquids ना, ये दोनों होते हैं. So the beauty is when they're both liquids, कौन से? When slag and iron at 1000 degrees, liquid है ये भी और ये भी liquid है, इनकी density फर्क होती है. Density is different. So when the density is different, what can happen? They'll separate. And this is lower density. And why? By default, always remember that transitional metals have very high density. Okay, always remember that. And so, because metal, always remember this, transition elements are highly dense. They sink, dense. Can you remember that? So when you do get them in the liquid form at the bottom, they will be two layers. So whatever container I have, they literally will have two layers. Niche iron hoga because it's heavier, and on top of it is your kachra, slag, which is lighter. And then उसको यहाँ से निकाल लें, उसको यहाँ से निकाल लें. Iron है, वो slag है. But if they were not liquid, they would not be able to separate. But they were liquid, so they would be able to separate. All right? Make sense? Mm-hmm. 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 Okay, awesome. All right. Okay. So that's metal extraction through reduction, पहला वाला. ठीक है ना? Now, okay. जिंक का भी बाय द वे हम पढ़ते नहीं हैं, बट यही तरीका है. लिटरली यही तरीका है. Okay. Zinc is also, because it's the same idea. If something is more reactive than coke, यही करेगा. So I just show you, because zinc is less reactive than carbon. Carbon can react with zinc to become zinc and carbon dioxide. वही चीज होती है. Exact same to same. Okay. Yeah. Or zinc oxide plus, you don't have to learn this, by the way. This is not in your syllabus, but I'm just showing you. Okay. So, but for the exam, this is not in your syllabus. It is, but you should understand it, not in whatever the fuck, you know. But yeah, you get what I'm saying, right? Yeah. Okay. So, अच्छा हम copper की बात आते हैं, ठीक है? Now, you can say, well, I can use this for copper also. But why do the khwari for copper? Because check this out. Now, let's forget the first. Let's say group 1, group 2 to group 3 वहाँ आ गए, right? फिर था हमारे पास कार्बन. और कार्बन के नीचे क्या थे हमारे पास? Yeah, not even in IGCSE, Zarisha. No, nowhere. Because they want you to learn one example, and iron is that example, because iron is so much more useful for us. So what was below carbon? Remember? Zinc, iron, lead, and then what was after lead? The killer, hydrogen. Yeah? And उसके नीचे क्या था? Copper and silver. Now, carbon, what happened? Okay, my screen got stuck for a second. Okay, so carbon can be used for anything below that. ठीक है? Carbon can be. But why should I always use carbon? At least I can use it for the metals, the ones below it, right? But when I go to copper and silver, then remember why could I use carbon to remove iron from it? Because carbon was more reactive than zinc and iron. But जब मैं copper पे आता हूँ, तो carbon isn't the only thing that's more reactive than copper. Even hydrogen is more reactive than copper. So we use hydrogen you can extract copper from it. And this is a very, very popular question in the labs. ATPs में आता है. You don't need carbon, na? Because remember, the whole problem with carbon was what? Carbon was a solid, and these are also solids. So we had to first convert it and all that. So reduction with hydrogen can also make copper. What hota kya hai? Now, what's a good ore of copper? Copper oxide. You might have heard of copper 2 oxide. Now, I'm going to write copper 2 oxide because copper 1 bhi hota hai. Now, copper 2 oxide ka you're even told to learn the color. It's a very important color to learn. Do you guys remember the color of copper 2 oxide? Black. And the idea is that if I pass pure hydrogen gas over copper oxide, simply speaking, because hydrogen is more reactive than copper, what happens? Copper forms and hydrogen takes the water. So hydrogen accepts the O from copper. क्यों? Because hydrogen का काम क्या था? Hydrogen gets oxidized and copper gets reduced. And how do I know that? Oxidation states +2, 0, and hydrogen 0, +1. So hydrogen undergoes oxidation and copper undergoes reduction. So this, I always turn to answer my, I always want to क्या कहते हैं, label oxidation reduction using oxidation states. Aisha, I have no idea what you mean. Let me finish this and then you can ask that. I don't know what a QSABT ions. Sir, I have a question. Acha, about ions that is not relevant here. Okay. But you want to ask them, can you wait for 5 minutes? Yes, Laiba, we'll have that. We'll have that also. Yes, yes. I will detail how and when I'm finishing what chapters also. Okay? Is that okay? Anyways, so where am I? I'm somewhere, I believe. Yes. So क्या कहानी है जी? हाँ, कहानी ये है. Let me say it again. So what am I doing? Copper from copper oxide using copper oxide plus hydrogen, and you heat it and you get copper and you get water. That's it. That's literally it. And you can even see the color change. You can say and abhi yaad kar lein aap. Even though we'll do color later, learn it right now. It's easier to learn individual colors separately than to learn 15 colors at one go. So copper is a black oxide, while copper metal is pink, a shade of pink. Yep. No. Copper solution is blue. Hey, Ali Abbas, copper 2 plus aqueous, which is a different form, is blue. Like copper sulfate aqueous is blue. Copper nitrate aqueous is blue. Not copper metal. Okay? Now, somebody had a question about ions. Was it to do with copper ions or other ions? Copper salts are blue. Copper salts. Aqueous form में या hydrated form में. Copper, you can call it pink becoming black or reddish orange or orange brown. है pink, but with some impurities, because उसकी surface थोड़ा सा copper oxide बना देती है, तो वो काला होना शुरू हो जाता है. If you ever played with wires, then copper, pure copper in the wires is very orangish, pinkish orange. And then over time it starts becoming black, because that's copper oxide forming. All right? Okay. All right. So we got through. Now what we did 2 examples. What we did, let me recap. So we were doing extraction of metals using reduction, because वो metals को reduce कर दिया हमने. ठीक है ना? क्या क्या थे? Fe2O3 से हमने कार्बन मोनोऑक्साइड से रिएक्ट कराया इसको, और इसको हमने बना दिया जी carbon dioxide and iron. And that was with carbon. And the less reactive ones like copper can react with hydrogen gas to make copper and water. Sorry. Okay. इसमें solid ये था, gas, solid, gas. इसमें solid gas makes it liquid and gas. Okay, Arisha, some precipitates dissolve in excess. Only 2 precipitates dissolve in excess. Remember? Do you know which ones? Okay, now she's asked another question, so I can answer that. So, okay, Aisha, I'm saving that question right now. Give me a minute. Others have asked. I've done what I've just wanted to do for today. Guys, these are the 2 reactions of metals using reduction. Obviously, There is more extensive for the blast furnace because you had multiple parts to it. You had carbon to carbon dioxide, then carbon dioxide to carbon monoxide, and all the same time you also had the impurities का वाला part, and उसमें calcium oxide plus SiO2 becomes slag, calcium silicate. Okay, yes, it will seem like you have to ratify some things, and I'm sorry, in O levels and IGCSE for chemistry syllabus sucks. I think it's stupid. I don't think this is any need to do this chapter in O levels, but I don't make the syllabus. I think there's less understanding and more rote learning in the O level and IGCSE syllabus, and I find it annoying. By the way, both का content similar होता है, almost content is very similar, is the testing questions that are different. Alright, so once done this, can I answer now Aisha's question? Alright. Zinc and copper, Laiba, I don't understand that. What is that? You're answering my question about Aisha. Actually, there are only two precipitates that dissolve in excess, okay, in NaOH or ammonia. And वो हैं आपके aluminum and zinc in NaOH, ठीक है, and copper in ammonia. I know that, right? In aqueous ammonia or ammonium hydroxide. Iron doesn't. So one way, there is a reason obviously, and you haven't done that, and you will not do that till A level second year, called complex ions. Okay. The trick is practice, but one trick is that these guys are amphoteric, but बाकी सबका scene यही है कि they make complex ions. Any and all that you have to learn, just make complex ions. And so even chromium, even copper, no matter which ones you know, but the why cannot be explained to you from the theory that you guys know in O levels. So you'll have to take our word for it. Okay, you do. You will have to. Okay, and apologies for that, but I would like you to. Okay. All right. Yeah. Okay. Sorry. What question? I didn't see that. If you have mids in 1 week, well, depends on how weak or strong your theory is. If your theory is really weak, just read the notes or the books. Either or. Books or notes. If your theory is half decent, then revise it through past paper topical questions. That's what I would say. All right, Saad? Oh, Sayyid Ali Abbas, you can start the practice from February and that'll be fine. Yeah. All right. Just don't waste the days, is what I'm saying. Okay? Now, listen to me. Listen to me. I need some favor from you. Can you do me a favor, everybody? Yes. Okay. So, there's some things in life that if they're awesome and you get them, you don't share, because if they're shared, they become less awesome. And what I need for you is to spread the word amongst as many friends and people that I'm doing this for free online, and I would like I want to teach as many kids as there are in Pakistan, and I'm not getting that. If you could just spread the word around, dude, this guy, please, it'll just make my life more fun. The more kids are in class, the more fun it is, honest to God. I can answer more questions, I can have a more entertaining time about it, and everything else is a free class for the whole year. Okay? Yeah, good luck for him. Okay. But yeah, thank you very much. Just share it as much as you can. Spread the word, spread the good word. And so in the end, we'll do well. All right. Okay. So I'll tell you what we're doing in the next class also. And I'm going to also start creating some video lessons separately on videos, specific videos. So, so next class is acid bases. All right. Acid bases, pH, neutralization, then reactions of metals again, and then yeah. All right. Then electrolysis. I'm not starting any new session for O-levels MESAM. They'll have access to all my earlier lessons on YouTube. They can watch them. I'm going to put them up. All right. We have 24, 25 by what? What? I don't understand what you mean by that. Yes, Laiba, they are, but they don't show up for class. When we were on Zoom, there were still less people than they are here, by the way. You'll be surprised. Yeah. Anyway, so I'm done with this class, guys. All right. I'm going to see you guys now on Tuesday. But Tuesday, I'm going to see you on this platform. All right. Please remember that. Tuesday, here on noon. Okay. And we're going to make this work for ourselves. Noon and YouTube. All right. And I love you all. And have a great weekend. Khuda Hafiz. All right. As long as love only increases when you share it. So great, isn't it? Khuda Hafiz. And have a good weekend. And I'll see you guys on Tuesday. All right. Allah Hafiz. Khuda Hafiz. Bye-bye. Yeah.